Okay, so today we are working on EE2, that's expressions and equations 2, which is I can solve expressions with variables. Okay? I can solve expressions with variables. Now I'm going to show you this and you're probably going to think, oh, well that's pretty easy. Hopefully that's what you think anyway.
Are there any handouts?
Nope. Okay, so it's best for these to start with an example, I think. So we're just going to start with an example and we'll just kind of walk you through it from there. So you'll be given some information, and it will usually be formed like this. Evaluate, which also means solve, guys. Evaluate if B equals 25 and T equals 3. And then you'll be given something like this. You'll be given an expression. Like, say, 16 plus B. And you will need to evaluate that expression. Okay? Now, I know you can do it in your head, but I want you to do it a specific way. Okay? I need you to do this in a specific way. Please remember back what I said before we even started this unit. That a lot of it's not about getting the answer, but showing your steps to get the answer correctly. Okay? So, number 1, what you're going to need to do, substitute. Substitute the number for the variable. Okay, so that would be right here. Okay, so that's step 1. So what I mean by that is you're going to rewrite this, but instead of writing B, you're going to write the number that they gave you. So it would be 16 plus, what is B?
25.
So you'd write 25 in there. Then step 2, solve with order of operation. Well, this one's obviously pretty easy because we just have one operation. 16 plus 25, which is 41. But you'll notice I still have my B there, right? I still did everything like I did before. Right? So you might have something that's a little more difficult. Let's say you have 2B plus T squared. Okay? So again, step 1, substitute. So I'm going to rewrite this exact expression, but instead of the letters, I'm going to write the numbers. And again, they gave me the numbers. They told me what they were. That's part of the information given to me. So I'd write 2. Now I got to remember, 2 and a letter next to each other. What does that mean again? What does that mean, Isaiah?
Addition.
Not addition. Not addition. Miguel?
Subtraction.
Not subtraction. No. Mackenzie? Yes, it means multiplication. So I'm going to put a multiplication symbol. And I'm really going to want to start using the dot now, because I'm going to be using a lot of variables and I don't want to confuse the x for multiplication with the x for a variable. So I want to use the dot. Now B, what is B? 25. So I'm going to write 25 instead of B, plus T is 3, so I'm going to write 3, and that has an exponent of 2. 3.
If you were to, like, because some people write this plus and towards it's like a T? Would you have to put the T like that?
I usually put a little tail on mine just so you know it's a T.
Okay.
But, I mean, you know, just try and be clear when you're writing. Okay? Now I just have a regular order of operation expression that I can solve using order of operation. Which operation would I do first? I have 3 operations. Which one is first? Isaiah?
The exponents.
The exponents, yeah. Please excuse my dear Sally. Exponents. Alright, I didn't have any parentheses. So exponents, 3 to the power of 2 is? 9. Yes. Bring everything down. Okay, now my next step, order of operation tells me to do what? Multiply, thank you. 2 times 25 is? 50. Plus 9. I only have one operation left, so my answer is 59. Notice again, I still have my V happening. Okay? The correct way to show that work. Okay? Alright? So that's basically it, but it's going to be a little, slightly more complicated here in a little bit. It kind of is, yeah, a little bit. Okay, so, I want to make a little note here. One more example of 24 over t. Okay, now a lot of you had some problems on the quiz with the fractions. Okay, and this is part of the learning process for you guys, is learning when you need to leave things as fractions and learning when you need to use that fraction as division and go ahead and divide. Okay, so that's part of the learning process, but you got to start working towards knowing that information. Okay, bottom line is, typically, if the problem is given to you as a fraction, it needs to stay in fraction form. Okay, so you wouldn't want to change it to decimals without changing it back. Okay, so let's go ahead and do this problem. 24 over t. That would be 24 over 3. Okay? Now, again, know when to leave it a fraction or when to make it division. Well, 24 divided by 3 is 8. So I'd want to do the division on that one because I get a nice, easy whole number. Yeah. So it would be 8. Okay? Make sense? Good. Good. Okay, now, things are going to get slightly more complicated, but not too bad. Okay? And this is why I asked you to have your planner out for this next section. We're going to be talking about formulas. Okay? And formulas, we're going to be talking a lot about this year, and so this is just kind of the basic introduction to formulas. Okay? And formulas are specific expressions, but in this case, they're also called equations. And we'll learn more about equations as we move forward, but right now know that formulas are technically equations, but the way that you are going to be solving them, you solve them kind of like expressions. Okay? So just kind of keep that in mind. So notice that they're, you can kind of refer to them as both, although equations are more correct because they have an equal sign. There are specific expressions, equations, that show a relationship between variables. Okay. Now, this happens because when we interact with the world and when we learn things about the world through science and mathematics, we see that things have a relationship all the time. Okay? So, for example, rectangles. Does anybody know how to find the area of a rectangle? How do you find the area of a rectangle? What do you do, Burley? Yeah. So that's actually a specific mathematical formula. And we write that mathematical formula like this. A equals L times W. And if we were to look at a rectangle, okay, one of the sides would be the length and one of the sides would be the width. L times W. And that's where we get that ability to get the area. The relationship between this length and this width is our area, and it's always like that. Always. Okay? And there's a ton of things that we have learned about our world that we know have continual specific relationships. So that's why if you look at page 118 in your planner, right here, if you look at these shapes, all of these different things, a circumference of a circle, area of a triangle, area of a rectangle, surface area of a rectangular prism, all of these different things are, to find different, different aspects of these shapes, are called formulas, because there's specific relationships between the sides of these and the different parts of these shapes that give you the surface area, or the area, or the circumference, or the perimeter, or any of those things, the volume when you get to 3 dimensions. Okay, those are all called formulas, because these variables have a relationship that give you specific things you might need to know. Right? If you're painting a house, you might need to know the surface area, different things like that. Well, squares are still rectangles. There are more advanced mathematical formulas, like these ones here. You can see it's some very advanced math, but you see there's variables in there. There's D, X, C, okay, E. All of these are variables for different parts of mathematics. Now, granted, this is very advanced mathematics, not something we're going to be dealing with, but you can see these are formulas that are used. Okay, they're like real-world situations. Probably the biggest way you'll use formulas is in science. Science has a bunch of formulas. To find the mass density, there's a formula. To find speed, there's a formula. To find acceleration, there's a formula. To find the universal gravitation, there's a formula. Power, kinetic energy, torque. See the T, it tells you the T is going to equal your torque. The F is going to equal your tangential force. The R is going to equal your radius. And if you put in the F and the R, it's going to tell you what the torque would be. Okay? Wave motion. Okay, if you want to know wave velocity, how fast waves move, there's a formula for that. There's all these different formulas in science that you use a lot of. Newton's second law is a formula. Force equals ma, mass times acceleration. Okay, so all of these formulas are things we've observed about the world, and we said these relationships always happen. Anytime you multiply the mass of something times its acceleration, that tells you its force. It always works. These are things we've observed about our world. So it's pretty cool. Yes, Bridget.
Is Einstein's theory of E equals mc squared a formula?
Yeah.
Energy equals
yes. Times the speed of light, yeah. Einstein's very famous formula, E equals mc squared. Yeah, that's a formula. Okay? So yeah, they're everywhere around us. So we're going to take a look at a few basic ones today, just to show you how you're going to use this substitution to solve them. Okay? So we could never teach you them all because there's just too many to teach. Okay? But let's look at L and W. Let's say now that L equals 9 inches and our width equals 11 inches. Okay? We can use step 1, and we're going to write the formula, which we have already done right there. Okay? Step 2 is substitute. Just like we did up here for the variable. substitute for the variable. So we would say A, that's what we want to know, the area equals the length, which we said is 9 inches, so we put 9 there, times the W, which is 11 inches, so we put 11 there. That's the substitute. 3 would be to solve. That'd be order of operation. And then 4 would be to label, because we're talking about real, actual things, so they need labels. Okay? Real, actual things need labels. So we'd say A equals, now we just solve. There's only one operation there, so 9 times 11 would be 99 inches squared. Okay, so you see you can use the substitution there. This is the formal way to show how you get the area of a rectangle. Okay, this is the formal way. Yes, Reese?
Why would you square it again?
Because that's what you're measuring, how many squares are in there, how many 1-inch squares fit in there. And there's 9-inch squares going up this way and 11 inches going this way, so there's 99 1-inch squares. Yep. Okay? Also, there is a square. So if you have a square here, okay, we say the side of a square is just S for side, because all of the sides of the square are the same, right? Like we used L and W because they're different sizes, but we know on a square they're all the same, so we just say side, because we know no matter what side you're talking about, it's the same size. Okay? So the formula for that is A for area equals S squared. So now if we say S equals 6, then we substitute A equals 6 squared, and let's say that's feet.
36.
So A would equal 36 feet squared. Okay? Do you see why an exponent of 2 or something to the power of 2 is called squared? That's where it actually comes from. A square is side times side. And since it's the same side, it'd be like 6 times 6. Squared. Squared. Okay? Pretty good?
Yeah.